Hi everyone, I hope you're all doing great. Welcome to our beautiful platform of Deeksha, Karnataka. So today I'm here with a very important session, which is the bridge course of mathematics for the CET 2026. Okay, so what's the meaning of bridge course? The meaning is very simple that of course PU1 is over, and for the PU2 students, you are starting with, okay, there might be some gaps that is there between the PU1 concept and PU2 concepts. Okay, so to revise those gaps, to fill those gaps again, so I'm gonna use this session particularly. It'll be only one session where we'll talk about three chapters, very important three chapters. The first is going to be relation and function, second is going to be trigonometry, and third will be limits and derivative, of course little bit of that. So why these three chapters only, sir? Because if you see, these three chapters are directly or indirectly used in the concepts or the topics involved in the chapters of PU2 or 12th. Okay, so I hope you are okay with that. Let's start this session. I know your time is very important, so we're gonna start the session right now with chapter number 1 as relation and function. Okay, so let's begin. So what we have first thing is, have a look, looking at this chapter, no, the relation and function chapter, starting with the definition of relation. Yes, very basic of the chapter. What is that? It's in mathematics we talk about, you know, the way we connect to two given sets. Okay, so if you have set A and B, let's say if you have two sets given as set A and B, okay, then those set of ordered pairs, those set of, so your relation will be the set of ordered pairs which shows the connection, the relation, basically, of course the word is synonyms, so connection between two elements of two sets. Okay, that is called as relation. For example, I can define it in different ways. I can say the set of odd numbers with prime numbers. Okay, odd prime numbers means, let's say set A is all odd numbers and set B is odd prime numbers. Okay, let's see. So I can say the set A and set B. Set A is odd numbers between for the numbers between of course all natural number between or less than 10. Okay, so I'll say odd numbers starting from, okay, 3, let's say 3, 5, 7 and 9. Okay, 3, 5, 7 and 9. And set B, if I'm saying set B, if I'm writing here, let's say only prime numbers, so I'm gonna start with 2, we'll have 3, we'll have 5, and we'll have 7. We'll not have 9, we'll not have 10. Okay, so I'm looking for numbers which is less than 10 and of course more than 1. Please check the numbers, the set is defined like this, set A and B. Then the ordered pairs will look like this, 3, 2, okay, 3, 3, 3, 5, 3, 7. Okay, 3, 2, 3, 3, 3, 5, 3, 7. Again, you're gonna start with 5, 2, 5, 3, 5, 5, 5, 7. Okay, this will be called as your, of course, ordered pairs. So if you're writing a relation, the relation means that you have to write all these ordered pairs together. 3, 2 is your first element of the relation. Okay, next will come 3, 3. I'll keep going on till the last one, 9, 7. 9, 7. These ordered pairs are called as the relation for the set A cross B. Relation defined on set A cross B. We write like this: relation from A to B. Relation from A to B. That's how we define the relation. That's how we give the notation for the relation, and this is what it means to be. Okay, these are the ordered pairs. Okay, and how do we pick ordered pairs? The first element comes from the set A, and second element comes from the set B. Also, these elements in the set B are called as images of the elements in set A. Okay, so we call this the second element in the ordered pair. This second element in the ordered pair is called as the image of the first element from the set A, okay, and how do we define it? So in the relation, you see, a subset of x cross y. What is x cross y called, sir? X cross y is nothing but the Cartesian product of the set x and y. Over here I have taken A and B, right? You can take this as x and y also. Take this as x and y. So the Cartesian product means what? All the elements combination, 2 with 2, whatever I've written over here, 3 with 2, 3 with 3, 3 with 5, 3 with 7. These are called as what? The Cartesian product of the set A to B, okay, or x to y. Same goes till 9 cross 7. Okay, so if you see that for all the relations that you have, so the subset of x cross y is called a relation from x to y. Okay, so I've taken all the Cartesian product, but any subset will also be called as. So if I talk about only 3 cross 2, or 3, 2 will also be a relation, okay, between the sets x and y. I hope this is clear, right? A very basic part of this, the image part and ordered pair. I hope this is clear. Moving on to next. So what we have, Domain, yes, few definitions to remember. They might seem very easy to you, but I'm telling you they are very practical, very useful in the examination point of view. Okay, because questions will be directly based upon, they can ask you directly the meaning of domain, range. Of course, they're very simple, so you remember that automatically, but it is very important to revise them as well. So if you check here, domain, the set of all first element of the ordered pairs. You've seen the ordered pairs, right? 3, 2, 3, 3, and so on. So the first elements, 3, 3, check here, basically 3, 5, 7, 9. Okay, so these are the set of the first element of the ordered pair, that is called your domain. Basically the set A is called the domain. Please check, set of all first elements of the ordered pairs. You can't leave one out. It has to be all first element of the ordered pair is called as domain for the relation R from set A to set B. Okay, please check. Okay, so basically I'm talking about set A over here, which was given by, if you remember, 3, 5, 7 and 9, just writing for reference point. Okay, moving on the range. When we talk about range, you know, the second element in the ordered pair, not in the set B. Okay, for example, I can write a I can write a relation like this. I can have here 1, 2, 3, let's say, and I can have over here 17, 14. Okay, I can have the relation only like this. Let's say I don't have so I have here 2, 14, I have here 3, 14, and I have a number over here 21. So 21 is not part of any ordered pair. So the ordered pairs that I have is 1, 17, next ordered pair is 2, 14, and next ordered pair is 3, 14. These are my relations, right? These are my relations. 1, 17, 2, 14, 3, 14 is my relation. Okay, so if you check the second element, we have 17 and 14 only over here. So I can write the range for this as, my range will be looking like this. Have a look, 17 and 14. So you don't have, and yes, you have to write in the middle bracket. You can't write, you know, the small brackets. So you have to write this, the curly brackets, the middle bracket, because they represent individual elements. There's a difference of, okay, you can't write this bracket here when you're writing the relation, because you talk about individual elements, right? You have to write the middle brackets. I hope this is clear. Okay, very simple thing, but just for somebody who doesn't know this part, should know it. It's very, very important. Okay, great. It's important for the board's point of view, because that will reduce the marks. Okay, because in of course in the examination with CET, you have to pick the right option, so that at that point of time it doesn't, you know, becomes that important that at that point of time. But in the case of boards, it'll cause the reason for the loss of marks. Okay, so 17 and 14 is there. This is called as range. So basically only the second element of the ordered pair is called as range. I'll repeat myself. Second element of the ordered pair is called as your range, the set of that. Okay, but what is the codomain then, sir? Codomain is basically, if I write this as, let's say, set A and set B over here, my codomain is simply this set B, 17, 14 and 21. 17, 14 and 21. Now just to avoid confusion over here, because I've taken already example of the elements, so I'm going to change this to, what is it, 1, 2, 3. Okay, because I've already taken the set A as 1, 2, 3 over here, so now take the previous example. Okay, so let's write this as 1, 2, 3, because I've taken here another example, right? So let's just keep linked with that. So set A is 1, 2, 3, codomain is 17, 14, 21, and your range is what, dear? Your range is 17 and 14. 17 and 14 is your range. I hope this is clear now. They're very important to remember. Okay, you have to remember these ones. Now note is, now if you're looking for total number of relations that can be defined between any given two sets, set A to B of course, then you need to know two things. The cardinal number of the sets, okay, for A and B, of course. Okay, so if you have the cardinal number of the set A as P, NA represents the cardinal number. If you have forgotten, I can write this over here. It represents cardinal number. So what is cardinal number, sir? I have forgotten that also. Number of elements. It means number of elements in any given set. Okay, so number of element in the set A is given as P, means the cardinal number of the set A is P. Same goes with the element, the set B, also the cardinal number has given is as Q over here. The total number of relations will be given by, 2 power P times Q. What is this? It is 2 power P multiple basically, so P times Q. Okay, please check. This is the formula that you're going to use. Yes, it is important. Can be asked in the examination as well. So very, very important formula. Okay, Very useful formula for the exam point of view. Please make a note of this. Okay, of course you can download the class notes from, you have to join the WhatsApp channel if you're new to our platform. You have to join the WhatsApp channel. In that we release our every session's class notes, okay, in the PDF format. You can download from there and of course keep it as your reference, or if you want to make your own notes, again you can refer that as well. So what you're going to do, of course, please join the WhatsApp channel. The link for that is given in the video description. Okay, from there click on the link, go ahead, join channel. In that you'll find all the sessions PDF available to you. Okay, so this is clear. Moving on, next we have functions. Of course relation part is covered, sir. Let's move on to functions. So those relations, okay, so you might think about it. I'll start in a few seconds. First you think your answer, what is a function? Okay, now I'll give you my answer. So what is a function, sir? All those relations, okay, which has unique mappings, a unique, a relation between the domain. For every element in domain, you have unique mapping of those elements in the codomain. So what is the meaning of mapping, sir? I can say in different words or easier word. So for every element, the word is very important, every element in the domain, there exists a unique number in the codomain. Means one element in the domain cannot have two elements in the codomain. Okay, it might look confusing to you, don't worry, I'll show you the mappings later, but right now understand this. Okay, so if I take, let's say, set A like this and set B like this, okay, set A and set B like this, I have the, let's say, element over here 1, 2 and 3. Over here I have element A, B, C, D, A, B, C, D. Then I can say what? For the element, this is called my domain, right? And this is called my codomain. For the relation defined like this is a relation already given to you. They've given that this is a relation is defined from A to B. Now we are trying to call whether the relation given to us is a function or not. First of all, the relation is given from the set A to B. Now we are trying to say, identify what? Identify whether the given relation R is a function or not. Okay, how do we make a judge of that? Okay, so the judgment will be based upon if you have unique mappings or not. Means I can have mappings like this, but I cannot have mappings like this. Means the number A1 cannot be identified with two numbers A and C. Okay, you cannot have same numbers giving you two values in the codomain. Okay, you can't have two mappings like this. Okay, because for every number over here you have a unique mapping uniquely related to the element in the codomain. I hope this is clear. Okay, I hope this is clear. Yes, you can have this way. Please check. You can have this way. That is all right. Please check. From 2 to A, that's okay, because 2 is related to only one element. Basically, for every element in the set A, okay, or the domain part, there should be one or only one number in the codomain. Only one number in the codomain. Okay. Now, sir, is this a function right now? 1 and 2 is mapped, 3 is left out. No. The word is very, very important. Every element. You cannot leave anything behind in the domain part. You can leave behind in the codomain part, but not in the domain part. In domain, you must have to map every single element. So you have to map, let's say, 3 to D. Okay, 1 to A, 2 to A and 3 to D. So my ordered pairs are what, dear? 1A, 2A and 3D. This relation 1A, 2A and 3D will be called a function because it has all the conditions fulfilled. What is the condition? The condition is very simple, sir. It should be every element in the domain should be having a mapping, should be having a relation with the element in the codomain, and of course what, there should be unique mapping. You cannot have same element in the domain going to two different numbers in the codomain. So if we check here, the ordered pairs are 1A, 2A, 3D. So from here you can see the range becomes, the range becomes very simple, A and D. Your range is basically A and D. Range is basically A and D. A, you don't have to write the repetition of the element, right? So A and D is your range. What is the codomain? Codomain is A, B, C, D. This part is what, dear? This part is codomain. I hope you know that, right? Yes. This is codomain. This part is range, and of course, set A is the domain. Let me read the definitions now. A function is a special type of relation in which every element of the domain is related to exactly one element. Unique. I said this word unique. This represents unique. Unique mapping means the same thing. Exactly one element in the codomain. Okay. Set A is known as domain of F and set B is called codomain. And also set of all images. What is this, sir? A and D are the image of the elements of domain, right? A and D are the image of the elements of domain. So the set of A and D will be called as range. The set of all the images is known as range. I hope this is clear. Range of f is given as all the values of x when you put it in the function. That will be your, of course, range. Range of function is subset of codomain. Think about it. I have range as AD. And what is the codomain? ABCD. Isn't AD a subset of ABCD? Right? So range of the function is subset of codomain. Okay? Note, a function is always a relation. So every function is a relation, but not vice versa. Not always a relation will be a function. Okay? Because if I left out, let's say 3, will that be a relation, sir? Yes. If I remove this part out, if I say the ordered pair is only 1A, 2A, question is it a relation? Yes. Is it a function? No. Okay? For function, it has to be, every element in the domain has to be mapped properly. Okay? Chaliye. So I hope this is clear. I hope this part is at least clear. Okay, great. So with this known, with this result known, I can move on. Okay, so next we have a look. So I've taken some mappings already, I've drawn some mappings. So explain you in what cases we can say the mapping represents a function or not. Okay, represents a function or not. Have a look. They're very simple ones. We'll see them one by one. So I've taken 4 cases over here: A, B, C, D. Let's see the case of A. So of course, a relation R is defined from set A to B. Sir, domain is set A. Sir, codomain is set B. Okay, so we'll not worry about range and all over here. We'll worry about whether the given relation is a function or not. Okay, great. Have a look. Sir, all first condition is each and every element of the domain should be mapped. So sir, all is mapped. Good. All is mapped. Good. Sir, every one should be uniquely related, sir. So this has unique relation. Yes, exactly one relation. This element has one relation. Okay, this element has one relation. Okay, this element has one relation. Sir, but they're both going to the same thing. It's all right. The point was each one of them should have exactly one mapping. Please check here. Exactly one mapping in the codomain. Okay, means every element should have exactly one mapping. Does this third element has one mapping or not? Does it have two mapping? No, sir, it has only one mapping, which is this element. What about this, sir? Yes, only one mapping. So that is condition. Okay, first condition was every element in the domain should be having a mapping, should be related to some element in the codomain. Of course, that's what the mapping means. And second was that each one should have exactly one. Exactly one. So of course this given relation is a function. This given relation, first case, is a function. Okay, so function over here is ticked right. Okay, next one. I hope the case A is clear. Let's move on to case B. So in this you see, oh yes sir, first condition is all the elements in the domain is mapped. So yes, all of them are related, not a problem. But check this out. For the first element you have this as your what do you call yes. So first, yeah, correct. No, this is mapped to this uniquely. Okay. Second one, you check. Second one is mapped to two elements in the codomain. Second one goes to this and this both. Is it a unique mapping? Means for the second element in the domain, you have two elements in the codomain mapped. It means not a function. This will be not a function because it's clearly mentioned that every element should have exactly one image in the codomain, whereas in the second element it has two images. It is going to this also and this as well. Means for the second element over here we have two images. So not possible. It means the second case B is not a function. Simply no. Okay, not a function. That is my choice. Okay, moving on. So case C, if you check, for the relation R defined from A to B, yes, all of them are mapped. Please check A. So all the 4 elements in the domain are mapped here and they're mapped to only one element. That's okay, because for the first element I have this as my result. Okay, second element is mapped to exactly 1. Third element also mapped to exactly 1. Fourth also mapped to exactly 1. The condition is that every element in the domain has to map to exactly one element or image of the only one element in the codomain, which is correct. It means it is a function, sir. Yes, it's a function because yes, they are all mapped to same element in the domain, in the codomain, but that's all right. We're looking for exactly one image. Does this have only one image? Yes, sir. Does the second element has only one image? Yes, sir. Does the third element has only one image? Yes, sir. Does the fourth element in the codomain, in the domain, has one image or not? Yes, sir. So every element in the domain has only one image. Yes, it is common in this case, but doesn't matter. It will be a function. Yes, so this is again, so case A and C is a function. Let's look at the case D now. Clearly, sir, not a function. not a function, I can say, because check here, not mapped, not mapped. So you have one element missing only in the domain, which is not related to any element in the codomain, which cannot be the case. Every element in the domain has to be mapped or related to some element in the codomain. So this is a relation but not a function. R is not a function. Okay, so try to take here 4 different mappings and show you whether which cases can be called the relation is a function or not. Okay, let's move on. So I hope this is clear. Next, so we'll talk about now the different type of standard functions, because they are very relevant and important to us. Okay, so they are knowing their domain, knowing their graphs, because it helps us solve the questions faster in the examination. So we'll see. First we have I've taken over here 3 simple ones: modulus function, constant function, identity function. So we have seen, of course, we are seeing the graph over here, and we'll also see the domain and range, everything. So please check. For modulus function, the domain goes, of course, all real numbers. Means it can take any number, it can operate on any number. Okay, so basically, now think about this. Actually, every function is a machine, sir, which has something as input and something comes out as output. Okay, so that input that goes in is called as your domain. What comes out is your range, which will be part of your codomain set. Okay, so of course, same way, if you check over here, modulus function also. So input part in the machine of the function. So if the machine is modulus function, your input is all real number. Your domain is input. So all real number is the input. What is the output? Only positive and 0. That's why we write this as all non-negative real numbers. Means I can take here all positive real number and 0 as well. Even the 0 over here is part. No, please check. Even the 0 over here is a part. Okay, not visible, the yellow color. I'll change that. Okay. So this, even 0 over here, no, will be part of the range actually. So range will be all non-negative. Instead of calling it to be all positive and 0, simply call all non-negative. Means the negative will not be there. The negative numbers is not there. This is clear. There is no negative in the value for the output of the modulus function. Means any number you put in the modulus function, the result is always positive or 0. Never a negative number. We know that, right? Very well. Mod, if you put a mod on any number, negative or positive, the result is either 0 or positive. Okay, so never a negative number. So I hope you get that. Let's move on. Next we have constant function. Basically, again, if you check the input in the machine of constant function, if you check the input, which is also called as, of course, what, dear? Domain. What is domain, sir? We know this very well. All real number. I can put any real number in the constant function. The output will be the constant that is we are looking for. So your output is called as range. What will be range, sir? The range will be the constant that is given to you, C. Means whether you take x as 0, 1, 2, 3, 1.111, 1.222, anything you take, the result is always this constant C, right? The result is always this constant C. That's why the range is only one number, which is C. That's how we define the function to be the constant function. The function is constant. Anything you take on x, y remains same as C. I hope this is clear to all of you. Next is identity function. This means that in this function, actually, in this machine, actually, if you put any input, output is same. Okay, so whether you take x as 1, y will become 1. The function is defined like this, right? Remember, y equals to x is your function. Over here you define the function as, you remember this, y equals to, this is constant, right? So C. This is the function definition. Over here, y equal to x, we have the function definition in the case of identity function. And if I'm writing the domain or the input of the machine, domain will be all real number, and your range is as well all real number. So your domain is all real and range is also all real number. I hope this is clear. Simple enough, fair enough. Please check the straight line will be passing from the straight line, passing from the origin, forgive me, and equally inclined to both x and y axis. If I have here 2x, it will not be equally inclined. Since I have here 1x, no, y equal to x I have. Okay, that's why it is identity function. So equally inclined, this angle you see, no, this will be, if I call this to be alpha, this angle is beta, then alpha and beta will be equal here. Alpha and beta will be equal in nature. This is called as equal inclined to both x and y axis. That's the nature of identity function. Let's see some more functions. These are very simple ones. The next we have greatest integer function, the GIF function, okay, and of course signum function. Okay, so let's look at the GIF first. So this function is very unique. Any value you put in, okay, any value you put in, whether it is a decimal number or number, what happens is it takes only the account of the integer part. Let's say I take 2.9. I take 2.9. There's a symbol for this. Symbol is square bracket. Okay, the symbol square bracket represents GIF. This symbol represents here GIF. What is GIF, sir? Greatest integer function. Okay, if you put here 2.9, what is the answer going to be? Simply 2. So any number you put, the value on the integral side will become the result. Okay, so basically the graph, if you check, so on the right hand side you'll have always a open sign. So check here, this at 2.99999, always whatever you take, it'll become what, dear? It will become 2 only. So if you check here, 2.999, what is the answer, sir? Always 2. But as soon as you go to 3, let's say we'll talk about 3, so it'll become a close over here, and this will be, sir, what? This will be 3 here, and again it goes on and open here. Okay, so at every integer, answer will of course be the same. Okay, if I take at 3, let's say, answer will be 3. Okay, so at all the integral value, it act as an identity function, but between that it will be giving you the value of the greater integer that you have over here, that which is 2 in this case. So you take 1.555, answer will be 1. Okay, if you take again same goes to negative side, minus 1 point something, if you take, it will be coming out as, please check here, minus 1 point something, it will become minus 2. Okay, if you take minus 1.5, it will become minus 2. Okay, again if you take between 0 and 1, it will become 0. Between 0 and minus 1, it will become minus 1. I'll repeat myself. Between 0 and 1, if you take any value, it will become 0, because over here we have open. Okay, and between minus 1 and 0, it will become always minus 1. Please check the minus 1. Okay, don't worry, we'll see more and more questions when we are studying throughout the year in different cases, whether it is talking about calculus or in ITF. Whenever we talk about GIF, I'll explain you these questions and this graph every time that I'm teaching you. Okay, so if you're learning for the first time, if you're confused still, sir, what is it going to be? I'll repeat myself one more time. What is that? This function gives you only the integral value. Okay, so yes, your domain will be all real. Your domain will be all real, but your range will be only integers, only z. Your range will be only integers. Okay, so this is how it works. 2.999 you take, answer will be 2. You take 3.001, answer will be 3. Okay, so whatever the value over here, that integer you have before the decimal, that will come out as your output. Okay, now let's move on to signum function, also called as, okay, please check step function, what we have over here. So signum function is very simple. Any positive value you take, of course positive means more than 0, answer is always 1. You take 1.5, you take 11.5, you take 11,005. Okay, doesn't matter. Whatever value you take which is more than 0, answer is always 1. Okay, and if you take any value which is less than 0, which is negative side, answer is always minus 1. So plus 1 on any positive value, for all positive values is plus, and for all negative value it is minus 1. Okay, and so if you check the domain, will be, of course, sir, all real. I can take any value inside this. Okay, and if you check the range is very unique actually. Range is only 3 numbers. What is the range, sir? Minus 1, 1, and one more thing is there, 0. Means when you take the function value at 0, it will become simply 0. It will become simply 0. So at 0 it is 0, after 0 it is 1, before 0 it is minus 1. Okay, please check. That's how we define the function mod x by x. Okay, so for when x is 0, it is 0. When x is non-zero, we have 2 definition, minus 1 and 1. I hope this is clear. Alright, so please check. So your range is written over here, minus 1, 0 and 1, and domain is all real. Okay, let's move on now. Next is exponential function. Of course, we have 2 graphs over here. One is when the base is less than 1. Okay, when the base is less than 1, the function is defined like this: y equal to a power x. You can see over here, y equal to a power x is the definition of the function. Okay, and if the value of a is less than 1 and more than 0, of course it cannot be less than 0. It has to be, the value of a has to be always positive. Okay, and cannot be equal to 1. So if it is more than 0 and less than 1, the graph is this. If you have a case which a is more than 1 also. A is more than 1. The function becomes this. Please check. Then the function is this. Y equals to ax. This is what, dear? 0, 1. Okay. So this is the case when value of a lies between open 0, open 1, between 0 and 1. Okay. When the value of a, the base of the exponential function, is between 0 and 1, no? Then you have this graph, okay, the decreasing nature graph. Increasing nature graph will come when you have a more than 1. Of course, it makes sense, right? Because if a value is less than 1, no? If you make, for example, think about it. Y equal to, sir, I take 0.2 power x. 0.2 power x. Keep increasing the value of x. What will happen? This will become smaller, 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 right? Because this is already a smaller number. You try to make it a power. You try to multiply it with such a big number. What will happen? Smaller number multiplied to itself at a larger amount of time. I take x as 1000 or maybe 1 lakh. Whatever you take the value of x. So as you increase the value of x over here, no, the value of y will keep decreasing because this value is less than 1. Okay, so of course you'll have this as decreasing nature. But whereas if you have value of a more than 1, basically think about it, y equals to 2 power x. You increase the value of x, sir. You take x from left to right. The y also increases, no? When x is 2, it is 4. When x is 5, 32, 6, 64. Okay, keeps increasing like that. Okay, so if you increase the value of x, y also increases. This is the trend over here for the exponential function when a value is more than 1. Please check. Again, if you check here, domain is always all real. So for both the cases, actually domain is the same thing. So domain over here is all real, means input is always all real in both the cases that you see, and range also is same in both the cases, which is always 0 open to infinity open. The function can never reach 0. Whether you take this side, it will never touch the x-axis. Here also, it will never touch the x-axis. It will always be very close to x-axis. It will never become 0. It will never become 0. So exponential function doesn't become 0. That's why 0 is open. And of course, nothing can become infinity. That's why also infinity is open. So range is 0 to infinity. Domain is all real. So input is all real. Output is only positive numbers. Output is only positive number. You don't have negative. You don't have 0 also. We can say only positive real number. I can say also this. I can also write this range as all real but only positive ones. I can write the range as all real but only positive ones, sir. Makes sense, right? Yeah, I hope this is clear. Let's move on. So next what we have is again inverse of this, logarithmic function. Okay, logarithmic function. This is again the case where how you write the function log of x with the base a. This is the case when a belongs to 0 and 1 open. When you talk about the other case, when a is more than 1, the graph changes to this. This point is nothing but 1, 0. This point is 1, 0, and this is again the graph of y equal to log of x with the base a, provided a is more than 1. More than 1. Okay. Again, a cannot be 1. A has to be always positive. This is to be the definition, the defining conditions. Okay. A has to be positive, and a is never 0. Okay. Always positive and never, sorry, not 0, never 1. Okay. Never 1. Always positive. Works out. Okay, if you check the domain over here very uniquely, domain in both the cases remains same, sir. Please check. First value, domain will be all positive, so I can write it like this as 0 to infinity. Domain is only positive real numbers. You can't have negative side of the x-axis involved over here. Only positive side of x-axis, not even 0. Okay, so we have 0 to infinity, or you can write this as simply r plus. What about your range, sir? The range in this case will be beautifully all real numbers. All real numbers. I can write here real. So all real. Okay, please check. Going up and down as well. Okay, so please check. If you see, one very important part over here, domain r plus, range all real. Domain r plus, range all real. Over here, look, domain is all real and range r plus, inverse of each other. The domain and range here is inversing the ones that is in the case of logarithmic and exponential function, because they are actually inverse of each other. No, logs and exponential functions are inverse of each other. Okay, I hope this is okay. Right? Again, if you take a standard log which is called as natural log, in the case of natural logs, you have the function going as ln x, okay, and this will become e power x. So these are the inverse of each other. Just one note if you want to use it, okay. So a special case of logarithmic function and exponential function, when the base is e, okay, it's called as natural log, and you have ln x and e power x as the inverse of each other. Again, the graph will be similar only. The graph is similar what I have drawn over here. This makes sense? Okay. Let's move on. What is next? Now the question that I have on the functions. They're asking the domain of the function fx defined like this, log. Find it out. Again, this is a very important question, part of a P by Q also. Let's solve this. Looking for domain. We know that domain has to be, the condition is what, sir? Domain means, we know that logs. Remember this, domain of the log. Only positive real number. It means always has to be positive number. Positive means what, dear? Positive means this value. If I take the first log itself, let's write that. So I have here log of 3 with log of 4x. It has to be positive, means more than 0. R plus means more than 0. So let's operate. We have one principle, remember. If I have here log x with the base a equals to y, I can write this basically x as a power y. A power y. The conversion between the log and the exponential function. Please check. So I'll have over here, if I remove this log first, so what I get, I have to keep this log as it is. So I'll write here log of x with the base 4. Same goes over here, greater than, and this 3 will become base. This a became base over here. Same way, this 3 becomes base, and this 0 will come as power. 3 power 0. Okay. So simplify this. 3 power 0 is nothing but 1, and I have here this as it is. Same thing I'm going to do again one more time. Remove this log. I'll have over here what left. Excuse me. I'm going to have only x left on this side, and 4 will go as the base. So I have over here x left. Same sign. 4 power 1. Okay. So I get the answer. This is again exponent. Okay. So I get the answer as x is more than 4. This is my domain, right? This is my domain. X value represents the domain. Okay. So basically it means 4 open to infinity. Both open, right? Because there's no equal to sign over here, only greater than. So this is my x belongs to, I can write this as domain. Domain is x belongs to 4 to infinity. Answer is option B. Answer is option B. Please check. Simple question. Of course, very simple. This is just for the reference part. This is just for the reference part, okay? The concept part. Please have a look. This is clear? Clear? Of course. Okay, let's move on now. So I think our chapter first one, which is R and F, is over now. The relation and function is over now. Now we'll move on to trigonometry. Well, we'll talk about some graphs, some domain and range, of course, and we'll see some formulas as well. Okay, so have a look. First thing is, what is an angle? So of course in trigonometry what happens is we work on angles only, right? Whether it is in the radians form or degree form, doesn't matter what, we work mostly on the angles only. Okay, what is an angle, sir? So angle is the rotation between two rays. Okay, so let's see if this is my first ray, the reference line. Okay, I hope this is clear. Please check. The reference line is this. Then I have another ray with the same end point. The end point is common, sir. This end point is common. Right now this can be the combination, the rotation. It is resting over here, right, like this. It is resting over here like this. I can rotate it like this with the one point common, one end point. The ray has only one end point. I know you have learned it, but just explaining you one more time. So ray has one end point, which is the common one in this particular case, the two rays, and it goes over here all the way till like this. Okay, now this is called as an angle. Okay, so of course you have learned this. When it is less than 90 degree, this is a 90 degree angle, something like this, I hope. Yeah, this is okay. This is a 90 degree angle. So excuse me, this is 90 degree angle somewhat. I hope I'm making this right. Yeah, this looks closer to 90. So this will be your 90 degree angle. If you have an angle structure which is less than, the rotation is less than 90 degree, means that is called as acute cases. And if it is more than 90 degree, we call this case to be obtuse angle cases, right? You've learned that already. See the rays? So you have over here, this is ray 1, let's call this to be ray as OA. Same end point if I have, this is my, let's say the ray OB. This rotation this rotation is called as the angle. We write with a simple, very common notation for the angle as theta. It's a variable, okay? So theta will be your angle swept or angle rotated between two rays OA and OB with the common endpoint as O. Okay, so condition is there should be one common endpoint, and the rotation, whatever it is, we take that to be the angle between the two rays. Okay, now so basically this is the measure of the rotation, right? Measure of the rotation. So we'll see how can we measure it. We're using two quantities. Okay, two ways. The ways are degrees or radians. Okay, two types of units that we have. So again, the rotation can be both clockwise and anti-clockwise. For this case, if you check here, I'm talking about anti-clockwise rotation. Usually whenever we see in mathematics, we take only anti-clockwise as positive. So we take this anti-clockwise rotation as positive, and we consider most of this time only positive, only we consider most of the time. So anti-clockwise rotation will be like this, and when we talk about clockwise rotation, please check, this is my ray OA, rotation will be below this. So this is my ray OB, and this will be your theta. Okay, so of course this is called as clockwise, and we consider this to be negative. Okay, we'll consider this as, so this is your reference line, this is a reference ray. Okay, go above this, basically going to be sweeping an angle which is positive or also anti-clockwise, counterclockwise. If you go below this, you'll be sweeping an angle which is negative, also a clockwise rotation. Okay, I hope this is clear. Let's move on now. Very basic things over here. Now the conversions between the degree and the radian measures, they're very important because sometimes it makes job easier. Let's say question is given in the terms of radians, but it is simple when you convert things in the terms of degree, and the calculation becomes simple and faster. So that's why you should know this. So what is that? If they have given to you degree measures, let's say the angle is given as 60 degree, or they've given the angle as 180 degree, or given the angle as 45 degree, then how do you convert those angles in terms of radians? So degree conversion to radians, we're going to use this formula, multiply simply the degree conversion given to you, degree value given to you of the angle with pi by 180. So whatever, let's say it's given as 45 degree, given to you as 45 degree, what are you going to do? Simply multiply pi by 180 to 45 degree, cancel this, so you'll have here 45 times 4 will be 180, multiplied 4 4s are 60, 16, okay, so you get the 160 degrees, 40 into 4 is 160 degrees, and 5 into 4 is 20, makes 180, right? So 45 times 4 is 180, answer will become what here? Pi by 4. So this angle 45 degree is nothing but pi by 4 in radian measures. Okay, so if you have been given degree measure, converting into radian will be simply multiplying that by pi by 180, and reverse in the case of radian to degree. Okay, if you're looking for radian to degree, multiply by 180 by pi. For example, if I have, let's say I have here pi by 3 given to me, I want to convert into degree terms, I'll multiply this with 180 by pi. Pi cancels, I have this answer as 3 times of 6 is 18, so 60 degrees. So pi by 3 is what, dear? Pi by 3 is 60 degrees. I hope this is clear. Simple calculations, you have learned that already, but recalling it once again, it's important this year as well. Now this table, for the special angles, standard angles, whatever you want to call, so of course the angles are 0, 30, 45, 60 and 90. 0, 30, 45, 60 and 90. One way, if you remember the table, is good only. If not, I'm going to give you one trick to remember it. If you remember sine, that's good enough. If you remember sine theta, you can remember cos and tan. Okay, I'll show you the trick. If you know, good for us. If you don't know, you can learn over here. So first thing will be, for sine theta, write the numbers here. So right here, 0, 0, 2, continue. 1, 2, 3, 4. Okay, basically in your mind, write the angle 0, 30, 45, 60 and 90, and start from 0, 1, 2, 3, 4. Divide every number that you've written by 4. What I'm doing over here, I'm trying to help you. If you don't remember the values, how to remember it quickly with the trick. Divide everything by 4, 4, 4. 4 here, 4 here, and 4 here as well. Okay, next thing will be taking the root. So first thing was writing the numbers from 0 to 4. Second thing was dividing every number that you've written for every angle by 4, and last was taking the root. When you do that, 0 by 4 is how much, sir? 0. Root of 0 will be 0. 1 by 4 is how much, sir? 1 by 4 is, so it's 1 by 4 only, you can't simplify that. Root of that will become 1 will be 1 and 4 will be 2. Answer becomes 1 by 2. 2 by 4 is how much, sir? 1 by 2. 2 by 4 is 1 by 2. What if this root becomes 1 by root 2? We have 3 by 4. 3 root is simply root 3 and 4 will be 2. So root 3 by 2. 4 by 4 is 1. Root of that is going to be 1. So that's how you get sine theta values. Now what about cos theta, sir? What about cos? So they are also called as, remember, complementary ratios. These are complementary ratios. Okay, so it means that the angles where it is complementary, no, they'll be equal. Means the angle of 90, complementary of 90 is what? 0. They'll be equal. Here 1 I have, it becomes 1. So complementary of 60, how much is that? 30. 60 and 30 is complementary, right? So whatever of sine will become same as 30 of cos. So please check. Cos 30 is root 3 by 2. Sine 60 is root 3 by 2. Same over here. 45 complementary is 45 only. So 1 by root 2, 1 by root 2. Same for sine and cos. Again, if you go over here, cos 60 will be same as sine 30 because 60 and 30 is complementary. You have 1 by 2, 1 by 2. And of course, if I go to cos 90, I have to go back to sine 0, which is 0. Okay, simply reverse this value that you have 0, 1 by 2, 1 by root 2, root 3 by 2 and 1 in case of cos. What about tan, sir? Tan is very simple. Tan is, sir, sine theta by cos theta ratio. Okay, that's how we define sine and that's how we define tan theta. 0 by 1 is 0. If you divide these two, you're going to get 1 by root 3 only. Divide over here, you're going to get 1 because the same thing. Or you're going to get root 3 in the numerator. And this will be undefined because 1 by 0 is not defined, no, 1 by 0, so undefined. 0 cannot be in the denominator, right? This is simply infinity. Okay, so once you get sine, cos and tan, you can get the others by reciprocating the sine for cosec, for cos, for sec, and the tan theta for cot theta, because cot is nothing but 1 by tan, sec is 1 by cos, and cosec is 1 by sine. This is the way to remember the table if you don't remember it, but if you remember, then very good. Okay, let's move on now. I hope this is clear. Now sine of the trigonometric ratios, okay, that we have total we have 6 ratios: sine, cos, tan, cosec, sec and cot. Okay, so what are the sign of these? Sine, cos, tan, cot, sec, cosec. So the table you've taken here, plus, minus, confusing, sir. I'll give you the way to remember it very quickly, don't worry. So right now we have to understand the quadrants. So I hope you know that already. The quadrants are very simple. First quadrant is given by, what is the quadrant? So if you take this plane, the coordinate axis, and you divide this, you get 4 quadrants over here: quadrant 1, quadrant 2, quadrant number 3 and quadrant number 4. If you remember my previous statement when I was teaching you about, explaining you about the your angles, check here. I'm taking what? I'm taking here again anti-clockwise. 1, 2, 3, 4. What is this, sir? Anti-clockwise. That's why I'm telling you every time we take what the angles to be in anti-clockwise direction only as positive. So 1, 2, 3, 4. Quadrant are like this. Okay, we don't take 1, 2, 3, 4. We don't take like that. Okay, always 1, 2, 3, 4. Clear? Okay, so we have total of 6 ratios. In the first quadrant, you'll have all 6 trigonometric ratio positive. You'll have all 6 trigonometric ratio positive in the first quadrant. In the case of second quadrant, you'll have only sine and the reciprocal of the sine. Sine and the reciprocal of the sine, which is what, sir? Cosec. Theta, let's call it. Only this will be positive, sir. Okay. In the case of your, excuse me, looks confusing. I'll just erase this. Yeah. In the case of the third quadrant, you have only tan theta and of course the reciprocal cot theta positive. And the last one, which is nothing but, please check. Fourth quadrant, you have over here the last cos theta and sec theta as the positive ones. Okay, so first quadrant we have all 6 trigonometric ratio positive. Second one we have sine and cosec. Next we have tan and cot, and the last we have cos and sec positive. Okay, basically if I'm talking about a theta value in the fourth quadrant, means more than 270 degrees, which is basically, it's called, this to be 300 degrees, it will be coming out as positive. Basically I'm saying that if you take cos of 300, you'll have a positive number, but if you take sine of 300, you'll have answer as negative. Okay, because only cos is positive over here. I hope you get my point. This is going to be 0 degree. It's going to be what, dear? 90 degrees. Okay, this will be 180 degree. I hope you know that already. And this will be 270 degree, and this will be what? 360 degrees. Okay, you also call this to be as pi by 2, pi 3 pi by 2 and 2 pi. Please check. Pi by 2, pi, 3 pi by 2 and 2 pi. Okay, so the boundary is also given. First quadrant is 0 to 90, 90 to 180, 182, 270 and 272, 360 is your value. Okay, I hope this is clear, very clear. So first quadrant all positive, second quadrant only sine and reciprocal, so cosec, third quadrant tan and cot, fourth quadrant cos and sec is positive. I hope this is clear. Please check. Now moving on. Let's see the graphs of the functions. So I'm going to draw the first 3 graphs and then show you the others as well. So I'll show you the graphs of all 6. So first one is y equal to sin x. Please check. Domain and range of the trigonometric function. If you check over here, the graphs is something like this. We know that domain is all real, right? So we'll take all real. Okay. Then the graph for sine goes like this. Okay. So this value is called as -1, the lower band, and the upper band is what, dear? The upper band is +1. Again, this goes on this side also. It continues. Okay, it continues on both the sides. So upper band is 1 and lower band is -1. Okay, this graph is for y equal to sin x. Of course, you can see here the range is limiting between -1 to 1, and your domain is all real number. You can keep going on both the sides. It will keep going on both the sides. Okay, so please check. If you're looking for one value to repeat itself, so for example this part to repeat will be coming over here, and this difference will be what, dear? There will be 2 pi, sir. So the value of the graph sin x repeats after every interval of 2 pi, means the same. If you see the next 2 pi, again the graph will be same. You check over here also, this is same, right? Not this, you'll have one more, so this will be same. So graph will repeat itself after every 2 pi interval. Got it? Moving on. Next is, sir, cos x. Cos x graph is again very simple. So at 0 it becomes 1 actually. Start from here and it keeps continuing like this. Excuse me. The last part is yeah. It keeps going like this, and over here also the lower band, if you remember, is always -1, and the upper band is of course +1. Okay. Again it will continue on both sides of x-axis, negative and positive x-axis. So you have the range again as -1 to 1, and domain is of course all real, and at 0 it will be what, here? It will be what? It will be a positive 1 value. Cos 0 is positive 1 value, and again repeats after interval of 2 pi. Okay, few things to remember about cos x also. This is the graph for y equals to cos x. Moving on, the graph for y equal to tan x. Okay, so of course in the domain part you have this odd multiples of pi by 2 not present. Think about it. Why not, sir? Because it will become undefined. No, tan 90 is undefined, tan 270 also undefined, like that. So odd multiples of 90, not even multiples. 19 to 1 is odd, 19 to 2 is 180. There it is defined. Okay, only at the odd multiples it is not defined. This is nothing but odd multiples. Please check. Odd multiples it is not defined. So we have 2n plus 1 by 2 pi. Okay, why 2n plus 1 is odd, sir? You know that, right? 2n means even number. Any number you multiply with 2, it becomes even. Plus 1, odd. 2 into n is an even number. Add 1 to it, it becomes odd. So that's why it is odd multiples of pi by 2 will be, there the function is not defined. So domain will be having all real except for odd multiples of pi by 2. How the graph will look, please check. You see the graph over here, x-axis, y-axis. So the graph will be like this. This is your first odd multiple, pi by 2. Again the graph will be pi over here, no? So we'll take it like this. 3 pi by 2. And again you can see here continuing like this. Okay. Okay. Here also same thing continues. This is a graph. Okay, so add the multiples. This is minus pi by 2, minus 3 pi by 2, and so on. So add the odd multiples. The graph tends to infinity, dear, on both sides. This is plus infinity and this goes to minus infinity. Okay, please check. This end goes to negative infinity and this end goes to plus infinity. Same goes over here also, plus infinity, minus infinity. So I can write here over here plus infinity. Over here we have minus infinity, of course. Okay, minus infinity over here. Got it? So plus and minus infinity. This also is minus infinity, of course. Minus infinity. this is also minus infinity, and this is plus infinity, sir, all the points. Okay, I hope this is clear. So your range is of course all real, your range is of course all real, and the domain is everything except for the odd multiples of pi by 2, because there it is undefined. You can see there's a break in the function at this point of time. Okay, there's no value. Somebody asks you what is the value of the function at pi by 2, answer is simply undefined. Okay, so odd multiples are undefined, again repeats after interval of pi, periodic after the interval of pi. Now see the graphs for others, graph that you have cot x, same thing, it will be just reverse of the tan. So you have defined at the odd multiples, but at the value of even multiple you don't have it defined. Please check. So it is defined at minus pi by 2, defined at pi by 2, defined at 3 pi by 2, but undefined at 0, pi, 2 pi, here minus pi and minus 2 pi, reverse of that. Okay, wherever the sine was, wherever the cos was 0, we had tan undefined. In this case, whenever the tan is 0, sorry, whenever the sine is 0, wherever the sine theta is 0, okay, you have cot theta undefined, which makes sense because you can write cot theta as what here? Cos theta by sine theta. Sine 0 means what will happen? It will become infinity, right? It will become infinity. That's why wherever the sine part is 0, it is becoming undefined. In the case of tan, wherever the cos part was 0, that's why we took odd multiples in the case of tan and even multiples in the case of cot. Okay, works. Again interval repeats after pi. Moving on. Now if you check the cosec, so everything was between 0 and minus 1 and 1, right? In the case of sine, here it is, please check, not visible, no, it is after 1 and minus 1. This is minus 1 band. Okay, so between that it was sine. In this case cosec will be again after 1 and below minus 1. More than 1 and less than minus 1. Okay, more than 1 and less than minus 1 will be the graph. So that's the nature of cosec. Please check. Okay, moving on. Again repetition is after 2 pi. Same goes with the case of sec also. Same thing, but of course the range will be different. Here it is undefined at, why like this, sir? Because it will be 0 at this point, no? That's why we are taking that out. It will be 0 at this point of time. Okay, if we take cos at odd multiple, it will become 0, right? Sine at even multiple, an integral multiple actually will become 0. N is an integer, so either integral multiple of pi or odd or even multiple of pi by 2. You can write the same thing, it means the same thing actually. You write even multiple of pi by 2 or integral multiple of pi, they are the same thing actually. Okay, so for all integer value, for all integers as I, n pi will be what? Cos n, sin n pi will be 0, right? Sin n pi is 0 when n is what, dear? When n is integer. Okay, then of course 1 by sin n pi, okay, becomes what, dear? Infinity, undefined. That's why we don't have that as part of the domain. You have taken that part out. Same goes in case of sec, cos. So your cos 2n plus 1 pi by 2 is 0. Odd multiples of pi by 2, it is 0. Hence 1 by cos, same thing, will become what, dear? Undefined. That's why it is, undefined. That's why it is not part of the domain. I hope you're getting it. Again symmetric about repetition in the interval of 2 pi. Okay, so I hope the graphs are clear. Please check. I'll show you once again all the 6 graphs. Sin x is like this. Okay, domain and range you know. Next is what, here? This is your cos x. At 0 it is 1. Tan x is again very simple, undefined at odd multiples of pi by 2, and cot x undefined at the integral multiples of pi, and you have again undefined for the cosec, undefined at the integral multiple of pi, and cot sec again undefined at the odd multiples of pi by 2. So I hope this all makes sense to all of you. Okay, moving on. From formulas we have trigonometric functions sum, and this is sum, sir. This is sum. Okay, sum and difference of 2 angles. Okay, we'll see all of that. Please check. So first thing will be sine of minus x. Sine of minus x will be simply minus sine x. Basically what it means is, if I take an angle below this, so let's see, this is my angle minus x. Okay, if I operate sine on that, simply sine minus sine will come outside. Okay, what about cos, sir? If we take cos of minus x, no, which this angle minus x is in 4th quadrant, right? Remember, cos in 4th quadrant is Positive, sir. It means whether you take minus angle also, it will come out as positive cos x. Okay, so positive cos x. Again, cos pi by 2 minus x. What is this? Understand this. There are 2 points to remember over here. Okay, whenever you're talking about trigonometric ratio operations over multiples of pi by 2, okay, so first thing is odd multiples of pi by 2. What will happen? Trigonometric ratio changes to what? Changes to complementary counterpart. Complementary counterpart. So what is the meaning of this? It means the cos will change to sine. The cos will change to sine. Remember this? Okay, so is pi by 2 odd multiple? Yes, it is odd multiple. Of course, pi by 2 into 1 you can write, right? So at odd multiples of 90 or pi by 2 or 90 degrees, okay, what will happen, sir? The trigonometric ratio that is given to you over here will change to its the complementary counterpart. Okay, so the cos becomes sine. You know the complementary ratios, right? You have the pairs as cos theta, sin theta, and vice versa. You have tan theta and cot theta, the complementary counterparts, and you have cosec theta and sec theta. These are the complementary counterparts that you have. Okay, please check. They are the complementary ratios. Complementary ratios that you have. Okay, I hope this is clear. Complementary ratio part. Okay, so cos theta becomes sin theta, sin becomes cos, and so on. Okay, so this is how it works. So pi by 2 minus x. Now, what is about the sign, sir, over here? Cos becomes sine. The sign part, I'm talking about positive and negative sign, that will change based upon the quadrant rule. The quadrant rule, sir, this is called as quadrant rule. This is called as quadrant rule. First quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, what you have over here? All 6. Here you have only sine and cosec. Here you have tan and cot. You have over here cos and sec. Cos and sec. Okay, of course theta is there everywhere. Theta is there everywhere. Okay, so pi by 2 minus x, which quadrant is this, sir? 90 minus theta, 90 minus x, first quadrant. So positive sin x. Again, sin will become cos, 90 minus x, first quadrant, so cos. We have cos pi by 2 plus x, means 90 plus x. So cos becomes sin. Cos becomes sin. Cos becomes sin. Why? Odd multiples of pi by 2. Cos becomes sin. Angles are which quadrant? Angle is pi by 2 plus x. 90 plus x. Second quadrant. This is 90 plus x means second quadrant. Okay. What is the ratio over here? Operating ratio we're going to look at. We're going to look at operating trigonometric ratio. Cos. Is cos positive in the second quadrant? No, sir. Only sin and cosec is positive. Cos is not positive. It means what will happen? It will become minus sin x. It will become minus sin x. I hope this is clear. I'll repeat myself. Pi by 2 plus x. Okay. Means what is this, sir? Second quadrant. Okay. Cos becomes sin. Of course, because it is odd multiple of pi by 2, and minus sin because of the operating function, which is cos. Okay, same goes over here. Sin pi by 2 plus x. Sin will be cos because it changes to cos. Okay, sin will be plus sin over here, not negative, because sin function is a positive function in the second quadrant. Okay, same here. Cos pi by minus x. We can write pi minus x also. No, think about it. Pi by 2 plus x is second quadrant. So 90 plus x is second quadrant, and 180 minus x is also second quadrant, sir. So cos will become cos only. Again, the rule, the second rule over here. First I've written over here, second here. At multiples of pi, okay, trigonometric ratio remains unchanged. unchanged. So at the odd multiples of pi by 2, no, it will change to the complementary counterpart. So at just multiples of pi, no, at the multiples of pi, what will happen? It will remain unchanged. So we have cos pi, right? It became cos only. Check here, sin pi, sin only. Cos pi plus x, cos only. The sign will of course matter from the quadrant rule. Pi minus x in second quadrant, that's why negative. Pi minus in second quadrant, sign is positive, that's why positive. Pi plus x is third quadrant, cos is negative, that's why negative. Have you getting it? So have you getting the quadrant rule, and the sign combination is very, very important because you're going to use this in the ITF, okay? And of course calculus part as well. Please check. Clear? Moving on. Same thing, sine at pi remains sine third quadrant, that's why minus. Sine at 2 pi remains pi because 2 pi is also integral multiple of multiples of pi, right? 2 pi is also multiples of pi. What multiples? I forgot to write here, integral multiples, okay? 1 second. I'm talking about integral multiples, okay? Of course. Integral multiples. 1 second. Integral multiples of pi, only integral multiples of pi, okay? So we have 2 pi also, same thing, sine will remain sine, and 2 pi minus x is in which quadrant? Fourth quadrant, so negative, okay? Cos 2 pi, cos remains cos, 2 pi minus x, fourth quadrant, cos is positive, that's why plus cos x, okay? So these are the quadrant rule with combination of complementary ratios. We have learned that. Now some formulas. Cos of a plus b is nothing but, sir, cos a cos b minus sin a sin b, or we can take in terms of x also. Cos x plus cos y. Cos of x plus y is cos x cos y minus sin x sin y. We have formulas for sin of a plus b or x plus y also, sin of x minus y, tan of x plus y also is there. Please remember and go through these formulas. Very, very important formulas. Extremely important formulas, both from the point of view of ITF as well as your calculus, where you talk about integration and conversion in the integration part. You're going to use this formula directly in the integration. So please download the class notes. From where you're going to download it? WhatsApp channel is there, okay? You have to join the WhatsApp channel if you're not joined already, and from there you're gonna get all the class notes delivered in the PDF format to you, okay? So you're gonna join it right now to have the PDFs available. The link for the WhatsApp channel will be given in the description. Don't worry, it's not a WhatsApp group. We won't get your numbers and all. It's a channel, okay? So the privacy will be, of course, maintained over there. You don't have to worry about that. Some more formulas. Cos 2x is nothing but cos square x minus sin square x, okay? 2 cos square x minus 1, or 1 minus 2 sin square x, okay? Or in terms of tan also is given, sin 2x. Please check. I've given a list of formulas for sin 3x, cos 3x, and tan 3x as well. Please remember, these formulas are very, very important. Just recalling it. You already learned it in PU1, but this is a bridge course. I want to revise the concept of PU1, which will be highly important in the learnings of your PU2, okay? This is clear. Moving on, some more formulas when you talk about half angles, okay? So not half angles actually. So when you take the combination of cos a plus cos b, okay, we have 2 times of cos of a plus b by 2 times of cos of a minus b by 2. We have cos a minus b, or x minus y, sin of x plus sin y, sin x minus sin y. The formulas are here, all 4 formulas. They are less used but important. They are less used but important, okay? Go from that. Again, same thing. These 2 formulas you see over here are related to each other, okay? So please remember both the formulas. Again, this case we have 2 sin x cos y, sorry, 2 cos x cos y minus 2 sin x sin y, 2 sin x cos y, and 2 cos x sin y in terms of sin and cos only, okay? Less used but they are important. Sometimes they can be used in the questions. Now one question on the trigonometry also, I want to solve it. Let's check what we have. So value of root 3 cosec 20 minus sec 20 degrees. Let's have a look. So let's convert this in terms of sine and cos, I think. Yeah, converting this in terms of sine and cos. So we have over here root 3 by sine 20 degrees minus 1 by cos 20 degrees, of course. So LCM will become sine 20 degrees and cos 20 degrees. So you have over here root 3 cos 20 degree minus sin 20 degree. That's how you take LCM, right? That's how you take LCM. Now do one thing, multiply by 2, okay, yeah, and divide by 2 also. So do one thing, in the numerator part, multiply here by 2 and divide here by 2, okay? And right here, root 3 cos 20 minus sin 20, okay? Of course, degrees here, and divided by same thing, 2 over here sine 20 degree and cos 20 degree again by 2. Now in this case I'm going to make use of the denominator 2. I'm going to move this 2 inside for both the terms. We are dividing by 2, now to divide everything by 2. Okay, so how will it look like? Divide by 2, here also divide by 2, and the 2 outside has to be of course taken out. I've taken the 2 which is inside. Okay, I've taken this 2 which was there, I've taken it inside, so it comes for both the terms by 2 and by 2. Over here I want to make use of this numerator 2. Please check. Okay, so my next step will look like this. So I have over here 2 of course is multiplied outside. Have a look, and root 3 by 2 will become what here? I can write this as sine 60. Okay, sine 60 degrees. Root 3 by 2 is how much? Sine 60 degrees, and cos 20 is as it is, minus sine 20 by 2. So I write sine 20 as it is, and I write 1 by 2. This is what? Sine 20 by 2, right? So I write 1 by 2 separate. 1 by 2 will become what here? Cos 60. You have the formula for that? Okay, cos 60 is 1 by 2. So writing the sine 20 as it is and 1 by 2 as cos 60. That is clear. Divided by, have a look. So 2 sine cos. Formula for this is sine 2 theta. I have shown it over here. Please check. 2 sine cos is nothing but sine 2 times of the angle. So sine twice of the angle 20 degree. Okay, we'll write that over here. Sine 2 times of the angle 20 degree, of course divided by 2. Okay, this 2 is left as it is. Now I'm going to move this 2 up over here. This becomes 2 times 2 is how much? 4. Over here what I have? I'm taking this 2 up, right? It becomes, division is there, it will become multiplication, no, if it goes up. So we have 4, and over here we'll have sine A cos B cos A sine B. Okay, sine A cos B and cos A sine B. It becomes sine of 60 minus 20. Okay, and we have over sine 2 times 20, sine 40. Okay, so it gives me 4 times of sine 60 minus 20, sine 40. Numerator, please check. 60 minus 20, how much is that? 40 degrees divided by sine 40 degrees. Cancel, cancel. Answer is simply what here? 4. Answer is simply 4. Please check. Answer is simply 4. Option D is correct. I hope this is clear. Please check. Option D is correct. I hope this is making sense. Very simple. Extremely simple. Okay. So this is fun. Simple question. Which uses the complication, which uses the formulas of trigonometry from what? The also uses special angles. Okay, sine 60 degree, cos degree, 60 degree we have used over here. Use the formula of 2 sine cos as well, and sine of A plus B. Some of the angles they have also used over here. Please check. Very simple. Done. Okay, so next is what? Next is the last chapter, which is again very important to us, is limits and derivative. Okay, so we have done the first chapter, which was relation and function. Of course, I'm quickly revising these chapters, not in detail. The point is very simple because I want to cover up everything which is there, explain you some questions over it as well. So I've taken one question only, but don't worry, we'll see more questions coming once whole series starts. But right now, this is in the bridge course, only this is more than enough to recall the concepts. So 2 chapters are over, relation and function, and second is that we covered right now, trigonometry. Next is what, sir? Limits and derivative. The question comes for limits and derivative is, why do we need it? Okay, why do we need it? So we have certain functions, okay, for example this, where it's difficult to define the function at any given point. Let's say I call it define function at f of 2. You'll say infinity. You'll say infinity because if you do that, it'll become 2 minus 2 denominator. It'll become simply 0, sir. You can't do that. Okay, means function at 2 is not defined. We can say simply this is undefined. Simply it is undefined. Then comes the limit into picture that talks about, okay, we're not able to find the function value, but we can find the limiting value of the function. So we can't find the value of the function at 2, we can find the limiting value of the function at 2. What it means by that is, instead of writing x equals to 2, we go and write x tends to 2. We ignore this, we go x tends to 2. Means we'll not reach 2 exactly, but will be in very, very close approximity of 2. Okay, means will not be, if you check the number line, will not be on the 2, but will be very, very close to 2. Very, very close. Is the number 1.99 true? If I write here x tends to 2, does it mean that x is equals to, x is equals to 1.99999? No sir, it's not, doesn't mean that. Because if I write that, I can write here, this will be a finite number actually. Okay, I can write one more 9 over here, one more 9 over here. So it will never be ending, means x tends to 2 means I can never reach 2, but very, very, very close to 2. What number is that? If somebody asks you x tends to 2, what number is that? Answer will be, there is no number as such. You cannot have a finite number meaning to x tends to 2. Where is it? Very close to 2. X into 2 means very close to 2, okay, but not at 2. We cannot say, let's say I write 10 times 9, then I can write, somebody comes and write 11 times 9, 12 times 9. You can keep going on like this. After decimal point, you'll never reach 2, okay. Sometimes we can also see, okay sir, what about this side? 2.00000001 over here. Will this be number what it means to be x into 2? No, because I can continue like this, no? 0 0 and keep putting more zeros over here, so I'll never be ending. Even this is incorrect. So when I say x tends to 2, I mean that you cannot reach that. It doesn't mean any finite value. Not a finite value. That's the beauty of it. X tends to 2 is not a finite value. So if you want to summarize all of this, what it means is actually, when I say x tends to 2, it basically means, it implies x is not equal to 2. That's what it means. Okay, so simple, simple implications of this symbol x tends to 2. How you read this as? X tends to 2 means is x is not equal to 2. That is one thing which is clear. Okay, it's not equal to 2. Is it before some value? We cannot reach that. We know it is right before. Where is it, sir? Right before. Okay, means if you take one more step, you will reach on 2. But is that step before 2 defined? It's not defined. Okay, one step you take, you're going to reach 2. But can you define the current step which is before 2? You cannot define that. So not a finite value. It is simply defined as x tends to 2, and it can be meant as x not equal to 2. That's the beauty of it. Now the function becomes definable and of course solvable as well. So please check. I'm going to erase all of this. So once I write x tends to 2 not equal to 2, once I write x tends to 2, what happens is, have a look. It implies x not equal to 2. It means x not equal to 2. In that case, I can simply say what? Have a look. I can simply say the function fx is defined like this. X minus 2, x plus 2 divided by x minus 2. I can cancel this. Because, sir, I'm talking about x is not equal to 2. Because we're talking about x tends to 2. So the function actually becomes like this. Fx equals to x plus 2, where x is not equal to 2. If you're writing only this much and write this equals to x plus 2, this whole thing is wrong, sir. But if you write x plus 2 with the statement of x not equal to 2, then it is correct. Okay, then it is correct. Alright, so you can see the difference now. This is not right because you have not written here x not equal to 2. But when you write x not equal to 2, then this statement is, function definition is correct. Okay, now you can find the function value, no? So the limiting value will be given like this. So limit of the function fx, okay, when x tends to 2, not equal to 2, tends to 2, what will happen, sir? You'll get this value to be 2 plus 2, which is 4. See, when we are putting the function value at x, we are getting infinity actually. But actually the limiting value is giving me 4, which is much acceptable. So two things to remember over here. X tends to 2 means x not equal to 2. Second thing is, x tends to 2 is not a finite value, but limit is always a finite value. So if the limit exists for any given function, of course the limit cannot exist also in some cases, but if the limit exists, if it exists, the condition is if the limit exists, then it will always be a finite value. Is 4 not a finite value? Yes, it is. Let's see the graph of this function. The graph will look like this. If you see the graph of this function, the graph will look like this. X equals to, okay, x plus 2 we have. So we have this function over here. Please check. This is the point, x equals to 2. Okay, before and after it is okay. Okay, before and after 2 it is okay. Okay, so at this point you check what is the value, sir? Is 4. So at 2 it is of course not defined, but limiting value is giving what? Right before 2. Right before 2 what happens is it comes very close to 4, sir. This also is very close to 4. This is called as neighborhood of the point 2. This is called as, this arrows you see is called as neighborhood of 2. Neighborhood of 2. Okay, we define it like this. Very small value delta. So we write here minus delta to 2. Please check minus delta to 2. Okay, and of course will be union 2 to delta. 2 to delta. Okay, I hope this is clear. Okay, let's move on. Okay, so we have for the neighborhood of the point, no, what we talk about, please check a minus delta to a plus delta. Okay, so what I mean by that is, if I have a point a over here, okay, sorry, I went here minus, no, sorry, I wrote it ulta. I wrote it wrong, sir. So right here, like, so 2 minus delta to 2 plus delta will be your neighborhood of the point 2. Okay, so some delta means delta, what is delta, sir? Delta represents a very small value. Delta represents a very small value. Okay, so very small value before 2, after 2 will be your neighborhood of the point 2. Okay, same thing is written over here. So this is your delta minus delta, and this is plus delta. Okay, this represents your a minus delta, and this represents your a plus. The right side represents your a plus delta. Okay, this is your neighborhood of the point a. Okay, something called as deleted neighborhood. In this, what happens is, simply from the given neighborhood you take out a. From this neighborhood, no, you remove the a. So you can write like this: a minus delta, excuse me, basically what it means is remove the a from the neighborhood of a. Okay, comma to a plus delta, no. Can you see a is over here? Yes. Let's remove the a part. How you represent on the number line? Please check. This is your minus delta, right? This is your a, this is your plus delta, right? Just keep this as open. Here it is closed, nothing is there, no? Open. Okay, so remove a from here. How you write this? Simply write like this: a minus delta to a open, union a open to a plus delta. A open to, this, can you see this is open bracket, right? A open to a plus delta will be called as deleted neighborhood of the point A. I hope this is clear. Moving on. Okay, so next we have is, we talk about both LHL and RHL. Okay, so there's something called as, when can we say, the question is, when can we say for any given function limit exists. Okay, so basically whenever we have two things, RHL and LHL equal to each other. Okay, whenever we have RHL and LHL equal to each other, that when we call that function to be existing in nature, they meant to be existing in nature. Okay, please check. So how do you find RHL? So what is the meaning of RHL, sir? What is the meaning of RHL? RHL means that the point A in the right neighborhood of the point A. Basically, if I have the neighborhood like this, defined like this, please check. A plus means that on this side, this represents your RHL, sir. Whereas if I write minus, no, it means left hand side, it represents your LHL. Okay, and whenever you have this LHL equals to RHL, we call that limit exist. Limit exist. If you have, simply if you have LHL is not equal to RHL, you call what, dear? You call limit does not exist. This is useful because when you learn the chapter continuity and differentiability, you're going to use this concepts a lot. Okay, so that's why it's very, very important to learn the limits part over here. So what is RHL and LHL? The function, the limiting value of the function on the right neighborhood, in the right neighborhood of the point A, the critical point that you're looking for. Okay, so in this neighborhood on the right side of the of the point A, this value will be giving me what? The limiting value of this will be giving me RHL. Whereas this neighborhood will be giving me, the limiting value of the function will be giving me left hand limit. RHL means that right hand limit, and left hand limit means of course the left hand value in the left neighborhood of the point A. Okay, we represent this as A plus, you write the limit with x tends to A plus, and in this case you write the limit to be x tends to A minus. This is the standard notation to write RHL and LHL. For RHL we have A plus in the notation of the limit, okay, and in LHL we have A minus in the notation of the limit. Okay, basically it means the same thing. You're approaching the limit value. You're approaching the limit value from this side. Okay, this represents your RHL. When you approach the limit value of the function at the point A from this side, okay, is called your LHL. It's called your LHL. Now when you say bounded function, so for a function f, which is again defined for the any of your domain, okay, bounded in the given here condition is open A to B. Please check open A to B, and there exists some real numbers k1 and k2. So for all the x, for all the value of x which belongs to the interval A to B, okay, and for all those values of x, if fx, if the function value lies between the k1 and k2, the real numbers k1 and k2, okay, for any two real numbers k1 and k2, and for any x value from the domain from A to B, okay, in the interval, if it lies between the function value lies between k1 and k2, then we can call the function fx to be bounded in the region of k1 and k2. It's called as bounded function in the intervals of or in the between the real numbers k1 and k2. Okay, all right, let's move on then. Now algebra of limits. So of course, when can we use some questions like, you know, the addition of the questions with the limits condition, whether it is with the case of difference, also quotient, we'll see all of that. Okay, first one is of course, so sum and differences, you can check here. First one is sum and differences. Let's have a look. So first condition is that limit of the function fx and the gx at the point A, exists in nature. This is understood. Okay, that we are saying already that the function's limit at the point A exists. If it does not exist, then we cannot have this condition. If I had the limit to be does not existing in nature, then this will not be validated, of course. First condition is that the limit exists in nature. Okay, when that is true, when the limit exists in nature, then what happens is, then if you're talking about the sum of the two limits, sum of the functions, okay, so if you're looking to find the sum of the functions limit, simply find the limit of individual functions at the point A and then take the sum. I'm going to repeat myself. If you're looking to find the limit of the sum of the function, simply find the limit of the functions individually and then add the sum, add the result that you got. Okay, same goes in the case of difference also. You find the functions limit first and then take the subtraction. Okay, now in the case of product, same thing goes. You take the function limit first and then find the product. Okay, so you don't have to find the product of the function first. If you can do that, it's okay. If not, find the limit of the function individually, fx and gx, that is already known, and then multiply later, that also is okay. If you have powers, you can again take the functions limit and then take the power later also. Please check. Function fx limit is L, take the limit value first and then put the powers later. Okay, again if you're talking about the quotient part, very important, only thing is that the limit of this part, the denominator part, cannot be equal to 0. Please check. This is the denominator, right? This can never be 0. If that is the case, what is the condition? Condition is you can take the limit individually first, then take the division, the quotient. Okay, again over here same result is there. This is same thing, no? Fourth and fifth are the same thing. Sixth one, limit of the function fx is c and gx is L. You can use GOF over here. You can use GOF over here. Please check. Function fx at A is c and functions, the limit of the function gx at c is L. At A it is c and at c it is L. Then at A it becomes L. Please check. There's a chronology over here. Function fx limit at A is c. Function's gx limit at c is L. This is c. This c is going over here, is L. Then function GOF limit at A becomes L. Okay. Same goes in the case of modulus function. You take the limit first, then you apply the mod. It remains same thing. Okay. You take the limit first, L, and then apply the modulus on that. Okay. Moving on. Next, what we have? Excuse me. Yeah. Limit of the function e power fx. Again, what you do? First apply the limit to the function fx and then take the exponential powers. Okay, great. For log also same thing. You apply the log first, then you can take the log also. Of course, this has to be always positive. Why, sir? Definition of the log function. Definition of logs. The domain is always positive. Domain is always positive. That's why this is the domain, right? If you take the limit of on the fx, it will become domain. Domain has to be always positive value. That's the definition of log. Evaluation of the limits by using standard result. So this is one of the result, very important to us. Limit x power n minus a power n divided by x minus a is simply given by n times of a power n minus 1. N times of a power n minus 1, where n belongs to any natural number and a belongs to any real number. Okay, very important formula that we use most often. Now next what we have, evaluation of the limits when we have x tends to infinity given to us. Okay, whenever special cases, whenever we have the question over here x tends to infinity, what do you do actually? You divide both numerator and denominator by the highest power that you have. Okay, by the highest power that you have. Please check. In this case, you have x square, highest power, and that simply this condition. Limit, I'm going to write this again over here. The condition is the limit of the function, whatever it is given, 1 by x power n, whatever is the n value, when x tends to infinity is always 0. Always 0. Okay, 1 by, because infinity is what, dear? It means 1 by 0, right? If I'm writing here 1 by infinity, okay, if I write here 1 by infinity, sorry, 0, okay, it simply becomes 0 actually. Okay, so we'll solve this question. What's the step to use? First thing is divide both numerator and denominator by highest power of x. In this case we have x square. Divide every term. So we have over here 5, nothing will be left because x square and x square will be cancelled. Over here we'll have plus x. Okay, excuse me, let me write everything first, you see the result later. So 5x square by x square plus x by s square minus 2 by x square divided by what we have, 1 upon x square minus 4x upon x square plus 3x square upon x square. Agreed? Okay, so you have this and this is cancelled, this cancels, and what we have, cancel, and this one of the x is cancelled. Simplify this. Simplifying this will give me what, dear? We have over here 5 minus 1 by x, sorry, plus 1 by x, and we have minus 2 by x square divided by we have 1 by x square over here, and we have minus 4 by x, and we have over here plus 3. Okay, now for this part, what are you going to do? Apply the limit. What is the limit, sir? Limit x tends to infinity. When you do that, please check the result on this side. So we have limit will become 5 over here, because there is no x involved. It will become 1 by infinity, so simply 0. Please check this condition I'm using. Over here again minus 2 by infinity, it will become again minus 0 divided by over here 1 by 0 infinity square will be infinity only, so 0, and over here we have minus 4 by infinity, again 0. Okay, and last we have plus 3. Simplify, you're gonna get what? 5 by 3. This is my answer. Okay, so whenever you have a question which you are dealing with x tends to infinity, what are you going to do? Divide by the highest power of the numerator and denominator, and you get simplifying like this. Result will be simply 5 by 3 using this condition. Okay, answer is 5 by 3. Moving on. Okay, moving on. Evaluation of the limits of GIF, greater integer function. What do you do in this? So simply understand this. If I draw the graph of this, let's talk about the point 1 to 2. So at the point 1, actually, what happens is, at the point 1, please check. So at 1, it will be 1 only, sir. At 1.1, again 1. At 1.2, again 1 only. But at right before 2, it will be 1. It will be 1 only. But at 2, what will happen? It will become 2. It will become 2. Okay, now check carefully. So if I'm talking about, let's say, the function, if I talk about the function limit of GIF when x tends to 2, I'm going to split this into two parts. One is LHL, another is RHL. Okay, let's talk about LHL, sir. So when I talk about LHL, I have to approach the 2 from this side, approach 2 from the left hand side. This is LHL, right? This is my LHL. Check here, the LHL value will be 1, sir. It will be 1. This is my LHL value. But what about RHL value? Approach this 2 from this side. This represents my RHL. This represents my RHL. So anything after 2 will give me RHL value as simply 2. Please check. This will be your value as 2. So the function value at 2, RHL, the limiting value, at 2 will become 2. And before 2 will be 1. So your LHL value is 1, your RHL value is 2. What it means is your LHL is not equal to RHL, and what it means actually is the limit does not exist. Where? At 2. Add 2. What it means is basically 2 is what? Actually an integer. So does not exist at integers. I can write here integers. So at any integral value of x, at any integer or integral value of x in the domain of the GIF, the limit will never be existing in nature. But anything other than the integer value will be existing in nature. For example, you think about this point. Think about this point. Let's call the point to be 1.5. Call this point to be 1.5. Before 1.5, what is the answer, sir? 1. After 1.5, what is the answer, sir? 1. So any other value, what is that? Apart from the integers, okay? Only at the integers, the limit does not exist. Only at the integers. At integers. Please check. I hope this is clear. So at the integral value of x, the function limit will be not existing in nature because it becomes a and a minus 1. See, your LHL is what here? 2 minus 1, which is how much, sir? 1. Please check. 2 minus 1. How much is that? 1. In this case, it is simply a. Please check. 2. Okay. I hope you're getting the point. So for the GIF function, the limit does not exist at the integral point, and at the other point, it will always be existing in nature. So please have a look. This is clear. Moving on. What next we have? Okay, limits of trigonometric functions. So some standard values are there. Sin x by x limit when x tends to 0 is given by 1. Okay. Limit x tends to 0, sin x by x is 1. It can be taken as x by sin x also. Answer will become 1 only. Why, sir? Because I can take x below. Okay. I can write this as limit 1 upon sin x by x, x tends to 0, right? And it will be simply 1 only because I'm going to get what? 1 by 1. What is the answer? This part is 1, this part is already 1, okay? It becomes 1 by 1, so answer is 1. So both is the same thing actually, okay? Same goes in the case of tan also. Tan x by x when x tends to 0 is again 1. You can write x by tan x also, same thing, 1 will come, okay? Sin px by px will become so simply 1 when p is a constant, okay? When p is a constant, and same goes over here. Tan px by px is also 1, sir, when p is a constant, okay? Great. This is clear. Now moving on, sandwich theorem. So when we have three functions involved over here, hx, fx and gx. hx, fx and gx, okay? Such that the function value at point A for the gx is equal to same as hx function value at the point A. Basically, I'm trying to say here is h of A is same as g of A. Please check. G of A is same as h of A. Then by the limiting condition, what happens is they become equal to each other. Even the function f of A will be same. If this is, let's say, L, this also becomes equals to L. So the limit value of the function g or h is A. Even for f, it becomes equal to A. That's the definition of sandwich theorem that you can see from the graph here as well. Same thing I've mentioned in this case. Okay, let's move on. So now we have to talk about derivatives, okay? So in this part, of course, we're going to learn in much detail. So limits, yes, it is part of your PU1 portions, but derivative part is discussed in detail in the PU2 syllabus, okay? But since you've learned a little bit of it, I'm going to recall that over here, and so that it's going to be easier for you when you're learning the chapter, continuity and differentiability, okay? So where does the need of this term or this operation is there, okay? So how does it originate from? So if you look at any curve, okay, and I try to write something called as slope. Why slope, sir? If you know the definition of derivative, it starts as slope of a tangent of any given curve at a fixed point. At a fixed point. We'll see all of that, don't worry. So let's say this is a curve. This curve can be a parabola curve, it can be a circular curve, doesn't matter. Okay, so right now, so how do you find slope, sir? We need 2 points. Let's take 2 points. We'll draw a line like this. It's called as secant, okay, because I'm taking it outside as well, not just a chord. If you want, you can take a chord also, chord, just don't draw it outside the curve, okay? So I'll draw it as point A and point B. Since there are 2 points, it'll have coordinates, so write the coordinates as x2, y2, over here as x1, y1. I'll repeat my statement, okay? What is it? Slope term comes when we talk about the definition of the derivative, okay? So if you have to find the slope of this, I can write the slope m as change in y with respect to change in x. That's how we find slope. Change in the quantity assigned to the y-axis for any particular case. Let's say I'm talking about dt curve. Remember, distance time curve. Distance time curve, okay? what do we do in this case? Change in the distance with time is called as velocity, right? So y-axis, we have assigned the quantity distance over here. Here we have assigned on x-axis the quantity time over here. Okay, same way. So change in the quantity across y-axis, so y2 minus y1, that represents the change here. Y2 minus y1 divided by x2 minus x1 will give me the slope of the curve, sorry, the line AB, the secant, the chord, whatever you want to call AB. Okay, now if you keep moving this secant to a point where it becomes tangent, was it a property of tangent? It should have only one point of contact. Okay, so if we draw that, so if I have a line like this having unique or only one point of contact, which is, let's say, this point C, okay, then this line, if I call this to be, let's say, A dash and B dash, becomes what? Becomes tangent now. This becomes tangent now. Now, sir, how do we find slope of this? Of course, we need the value of this measure angle theta. We can write here the slope m is given by tan theta. So what if tan theta is not known, the value of theta is not known? Then comes a quantity called as dy by dx. What is this called as? The derivative of the variable y with respect to the variable x. What it means? Derivative of variable y with respect to x. With respect to x. WRT means with respect to x. Okay. Now what is the y represents here? Y represents here very simply the curve itself. The y represents here curve itself. Right? So if you take the curves equation, if it is a parabola, you'll have parabolic equation. Circle, you'll have circular equation. So whatever the equation given to you, either in this format or in the circular equation format, you know, x square plus y square equals to some constant will be there. So whatever the equation is given to you, you differentiate that by making y as subject. You're making y as subject. Okay, then you differentiate this, you get the value of derivative. You get the value of, okay, derivative, which is basically going to be slope. Going to be slope. So how do we define derivative? Slope of a tangent of any given curve at a fixed point. Please check this fixed point. C is fixed, sir. The C coordinate will be known. We have here, let's say, x3, y3 is the coordinate of the point C. So I'll have this derivative in terms of variable x and y, right? I have to substitute the x3 and y3 value in that variable to get the slope value or the derivative value at that fixed point. I hope this is making sense to you. Okay, so we'll get to what is there in the chapter, but right now understand what is the meaning of derivative. I've taken example of dt curve. Okay, remember the curve, if the same curve is over here, okay, and I want to talk about this. This was, remember, called as, so it was, I can draw it better, just give me 1 second. Yeah, just a second. So if I draw both the cases one more time over here, this case and this case, remember this slope was what is called as v instantaneous, means instantaneous speed, okay, whereas this was called was v average, average velocity or average speed. V average and V instantaneous. I hope this is clear. Let's move on now to the actual definition passed. So I think for the last year you had first principle. So we'll see that now. Yes, so now derivative from the first principle. So whatever formulas you will see or you must have seen by now comes and derived from this first principle only. Okay, so basic understanding of the derivative come from this principle where you use limit of the function, okay, in the neighborhood, okay, at the point when h tends to 0. Please check the neighborhood of the point h, okay. X plus h, f of x plus h minus f of x divided by h you use. This condition is called as derivative from the first principle. Derivative from the first principle. Everything that you see, all the formulas can be derived using this. You don't have to do that. That is because that is a lengthy process. Usually you can stick to the formula and get the results. That is much simpler, and that's how it used. Solve the questions in the examination, okay. But just understand this. You can see all the formulas can be simply derived using this particular condition of first principle of derivatives. Okay, let's move on now. So what we have, algebra of derivative functions. Understand this very clearly. This is not a lecture of derivatives. This is a bridge course. Means what are the concepts that you've learned in PU1 will be utilized in PU2. I'm just brushing up on those. Okay, it's not a full-time session of the concept derivatives. I'll do that later in our Sankalp whole series we are doing, right? The whole year series. In the Sankalp, it's going to be part of it. We'll do all of it again in detail. Okay, so do one thing for that. Subscribe the channel if you have already subscribed. Make sure that your notification is always turned on, because these are all very important videos, important classes. If you do not do it on time, you have too much backlogs. That's very very bad for your preparation journey. So make sure that you are finishing the task which is assigned to you on time. Okay, so let's continue from here. So algebra of derivatives of functions. So we have few laws over here: sum law, difference law, constant multiplication law. They are not very difficult ones, we'll see. So whenever you have two functions given as sums, means you're asked to differentiate two functions. Let's say I can say sin x plus x, okay, or I can have sin x plus x square derivative is asked to do. Okay, you have to find it. Of course, you'll know the formulas later, but I know the formulas, so I can just do it for you. Differentiate both of them, right? They asked to what? Differentiate both of them. I'll do what? I'll differentiate sin x first. I'll get it as cos x, and then differentiate this also next. I get over here as 2x, and then add them, and then simply add them. Okay, so what you can do is first do the individual differentiation of the functions that is given to you, and then last you can add them. Check here, derivative of fx and gx. You can write the derivative as this also, f dash of x plus g dash of x is also another way of writing the derivative form. Okay, notation is also either write d of fx by dx, d of gx by dx. If it is confusing to you at all, use the f dash of x plus g dash of x, means the same thing. Okay, now difference law, same concept that we used over here. First differentiate and then use the subtraction. Okay, first differentiate and then use the subtraction in the same order. So you have to subtract fx minus gx. So same order I've used in the derivative also. F dash x minus g dash of x. Of course, if there is a sign change in g dash of x, you have to incorporate that as well. Let's say this is coming as minus, then this will become plus, right? Correct, now? If the derivative of gx is minus, it's a negative value. Can happen if the function is cos x. Let's say if I have a function cos x given to you, if this gx function was, let's say, cos x, then you differentiate g dash of x, okay, as g dash of x, you get the answer as minus sin x, right? In that situation, this will become plus. But how will it become plus? Minus of minus sin x, okay, then only. So I have to keep the same order of subtraction sign in the case of difference law. I know it's very basic ones, but if any one of you is not able to understand that, it's very important for me to explain this concept even from the very basic level. Okay, so I hope you all understood that. Now constant multiplication. If let's say I had here a function given to me for this particular case, y equal to 2 sin x. I want to differentiate this. Okay, want to differentiate this. I'll write here dy by dx. Take 2, the constant you can take simply common, dear. You can take constant simply common. It becomes 2, sin becomes cos x. Sin derivative becomes simply cos x. So constant can be simply taken out. I hope this is very clear. Let's move on. Next is product law. When we have two functions given in product, okay, let's say I had what here? I had y equals to x square sin x, x square sin x. What are you going to do next? So in this particular case, you're going to differentiate the first one like this, 2x, keep this one as it is. So it will become 2x sin x. This time, keep x square as it is and differentiate sin x. So it will become cos x. So what we do in this case, I'll repeat myself. You differentiate any of the function one at a time. Why I say any? Because in the case of product law, there is no preference given to any of the functions. Okay, I'll repeat my statement. In the case of product law, there is no preference given to any of the statements, any of the functions. Okay, so I can do cos x first, sin x first, doesn't matter. Sorry, sin x first or x square doesn't matter. Okay, check here. So I've done x square first as 2x, sin x as remains as it is. Next is x square as it is, and sin x becomes cos x. Okay, this is the of course, if you are not able to recall these formulas, don't worry, I'll give you a list of all the formulas right now. Okay, and even when I teach you derivative, I'll give you all the formulas that is required. I'll teach you everything. So this is how you use in the product rule. I'm just giving you simple examples just to make sense for it. Next is what? The quotient law. In this case, you have preference given. What is the preference given to? The first derivative has to be taken for numerator functions. Excuse me. The function in the numerator. So the function numerator is what? F of x. So you're going to differentiate f of x first. So I can write here f dash of x. Will that work? F dash of x. F dash of x I'll write first, and then keep gx as it is. Keep gx as it is. Differentiate f of x. Okay. Put a minus sign. This time minus sign. Over here there was a plus sign. Please check. There was a plus sign over here. But in this case, in the case of quotient law, when the functions given to you, which is asked to be differentiated, is in fraction form, you're going to take the function in the numerator, differentiate that first, keeping the second function which is in the denominator as it is, put a minus sign. Next time, keep the first function fx as it is, differentiate the function in the denominator which is gx, please check, okay, divided by the function which is in the denominator, the whole square. So g is square of x, or gx the whole square. Okay, can you take examples, sir? Of course, please check. Sin x by x square if I have, differentiate this, so I get dy by dx. Sin x I'll differentiate first because this is in the numerator, right? I'll differentiate the numerator function first. So keeping x square as it is, different sin x, I get this as cos x. There comes a minus sign, so put a minus sign. This time keep sin x as it is and differentiate the x square. So for this I get 2x, okay, divided by this x square, the whole square. Whatever is in the denominator, square of that. That's your result, okay. So I hope this is very crystal clear to you. Not a problem at all. Simple topics, just recalling it from the PU1, okay. Let's move on now. Let's move on. Okay, now some formulas to remember, which are the very basic ones. So of course, starting from the polynomial one, if you remember, so if I have to write the first one, y equal to, if function is given to you a x power n, function is a x power n, okay. How do you differentiate this, sir? Very simple. I can write y dash, or simply your form dy by dx equals to, the constant a will remain as it is, the constant a will remain as it is, this n will come in front, this n will come in front, okay, and you have x power n minus 1. Example, sir, don't worry, I can take here x square or 2x square plus 4x plus 4 as my function, let's say y. This is my given function to me. What is the function, sir? Is it a polynomial function? Yes, it is. It's a quadratic function, okay. Differentiate it now. So I get dy by dx, agreed, okay, on this side. And for this, remember, I said keep 2 as it is, this constant keep as it is, and this 2 will come in front. So write this 2 in front, x as it is, keep the power 2 as it is and subtract minus 1. So 2 minus 1. Same way, 4 is a constant, keep the 4 as it is. Power of x is, sir, 1. So 1 will come in front, x power 1 is already there, minus 1. Check here, this is a minus 1, okay. And for any constant, we know this, derivative is always 0. For any constant value, derivative is always 0. Whatever is the constant, log, whatever it is, okay. If it is a constant, answer for the derivative is 0 for that, okay. So let's have a look what I'm getting for this. So I'm getting here 4, 2 into 2 is 4, x power 2 minus 1. So I get x over here. Again, for plus, I get 2 minus 1 is 1 only, right? I don't have to write the x power 1. Over here I get 4 times of x power 0. 1 minus 1 is 0. It means simply x power 0 is how much, dear? Going to be 1 only, right? This will become simply, please check, 1, and this is already a constant 0. I get the answer as 4x plus 4. 4x plus 4. Is this clear? Okay, so this is one example for the polynomial function. Now I'm going to list out some formulas for the trigonometric function. Not required to take example on all of this. I'll just take a list of all the formulas for trigonometric function. So if I have, let's say, y equal to sin x, okay, so for this my y dash, the derivative will become what, dear? Cos x. This represents what? Derivative. If you don't know, I'm just writing over here. Y dash represents derivative. So my y is sin x, y dash is cos x. Third one, if my y is cos x, y dash is minus sin x. Okay. Fourth one, y is tan x, y dash is, what is it, secant square x. Okay, derivatives. Next one, if I have y is sec x, so we'll have y dash as sec x tan x, secant x and tan x. Okay, next is, if I have y as cot x, get y dash at y dash as minus cosecant square x. Okay, and seventh one, so cosecant x, we have y dash as minus cosecant x. Okay, this is C, this is E, cot x. Okay, here we had sec tan, right? So it will become cosec cot. This is a minus sign, of course. Okay, these are the formulas for trigonometric functions, and these are the formula for your, this is the formula for your polynomial function, which is very, very, very important. Okay, I hope this is clear. Moving on, next we have what, some formulas for exponential function, for natural exponential function when the base is e, actually log x. Okay, and when the basically natural log x when base is e over here, the formula is 1 by x. When there's another base, some different base is given like a, I have the formula as 1 by x ln a. Okay, please check. So for a power x, we have a power x ln a. This log of e means ln, right? Log of e means same as ln, so I can write here a power x ln a. Same way, e power x remains e power x. Okay, log x derivative, log x, when I say it, what I mean is this only. When I say log x, I mean log x with the base e, also given as ln x. They are the same thing. Derivative will become what? Simply 1 by x. Simply 1 by x. Okay, simply if you have the case where the base is not e, here the base is e, here the base is a. When this a value is not equal to e, not the natural log value, then you have the formula as 1 by x ln a again. This is what's here, 1 by x ln a, 1 by x ln a. Okay, some more limits involving exponential and logarithmic functions, very important, please check. So limit of e power x minus 1 upon x when x tends to 0 is equal to 1. Okay, another theorem is limit. They are very useful in question, that's why I've taken over here. Limit, again natural log 1 plus x upon x is equal to 1. So these are the two formulas that you can remember. Let's move on to the next case. What we have, yes, now I have taken one question. I'm going to solve this and then complete the session today. Okay, so I hope this was fun so much. So this whole bridge course that I've taken, anything I missed, if you feel that this should have been added, let me know. I'll create a part 2 of it and come back and teach those topics and concepts to you. Works if I missed something. If not, then let me know how was the session. Let's solve this particular question. So we are given with fx. Okay, function is branched at the point -2 and the point 2. There are two variables involved. Variables are a and b. I'm going to find the value of a and b. Okay, great. They've given that limit of the function fx at the point 2 and at the point -2 both exists. Both exist. Okay, great. So let's do for the point -2 first. So if I'm going to substitute, find the limit, right? I'm going to look for what? LHL, RHL. At which point? At the point -2. Okay, so LHL I'm going to use this one. So I'll have here 3 minus -2 the square, correct? Putting x value as -2 for RHL. Simply a times of -2 plus b. Why can I do that? Why can I do that? Because there's no indeterminate form over here. Okay, if you put x as this value, no, there's no indeterminate form over here. I can directly substitute the value of x as -2. Now for the limit to exist that they've given here, limit exists, I have to put what? Equal to each other. Check this. I'm going to get here 3 minus 4. -2 square is 4. There's a minus sign. So 3 minus 4 equal to -2a plus b, which gives me how much? 3 minus 4 is -1 equals to -2a plus b. Let's call this to be my equation number 1. Because I have two variables involved, right? Variable a and b. I need two equations. So equation number 1. Equation number 2, I'm going to take another one which says limit exists at the point x tends to 2 also. Okay. Same thing we're going to do. LHL, RHL. Find LHL now. For this point 2, this is my LHL. Ax plus b is the LHL part. Okay. I'm going to take this, no, please check, less than sign. So this is my LHL part, ax plus b. So it will become what here? 2a plus b equals to, and for this side what we have? For this side we have 2 square by 2. Put x value as 2, right? So 2 square by 2. So I'm getting over here, I'm going to write the constant on one side. So it will become 2 square by 2 is nothing but 4 by 2, so 2. So 2 equals to 2a plus b. Okay, now put this back over here. I have minus 1 equals to minus 2a plus b. Add all of it. This is cancelled. 2 minus 1 is 1. This is my equation number actually. This part was my equation number 2. I'm putting this equation number 1 over here and then simply finding the value of a and b. Okay, so 2 minus 1 is simply 1. I have b plus b is 2b, which gives me the value of b simply as 1 by 2. You can see the answer is only one suitable option. B is 1 by 2 only over here. Hence option C is correct. Hence option C is correct. Please check. Okay, so option C is the right one. Have a look. I hope there is no doubt about this particular question. Very simple one. All right, let's move on now. So this is it for the session today. This was it in the bridge course of your Sankalp series from PU1 to PU2. As I'm telling you, if I have missed something, let me know in the comment section. I'll create a part 2 and come back and take those topics. So I'll see you again very soon. Till then, take care. Bye-bye.